Okay, so this lesson is properties of exponents. So some of this is going to be review, and then some of it may be new information. Your learning target is I can simplify expressions using properties of exponents. So these are from Math 1. These are your product rules. So I try to color code things. If you'll notice, if you have two bases that are the same and you are multiplying, then you can add the exponents. That's what that's saying. The next one, if you have two bases that are different but the exponents are the same, then you can rewrite them to look like this, where you would put both exponents multiplied to each other in parentheses, and then you would only write the exponent one time. Okay. Here are your quotient rules. So if you had two bases that were alike and you were dividing, then you could combine them by subtracting. That's what that first rule says. The second rule, if you have two bases that are different but have the same exponent, then you can rewrite them using just one of the exponents. Okay? Power rules. Okay, so if you'll notice in the first one, you have a base to an exponent to another exponent. So anytime that happens, when you have an exponent to an exponent, you just multiply the two exponents. The last two we're actually going to talk about a little more in depth because this is more Math 2 properties. So we're going to save those for right now. Alright, negative rules. You'd never want exponents to be negative, so if you had a base to a negative exponent, you would write it as 1 over base to the positive exponent. The converse of that is if it was already like this. So let's say you had a negative on the bottom, then you would move it to the top and you would make the exponent positive. Alright, so that's your negative rule. Zero rule. This one's really important. Anything to the 0 power equals 1. And now we're going to do some examples. Okay. So the first thing that I don't want you to forget is that you still do normal things like we are multiplying these two quantities together. 2 times 2 is 4. Now we're going to take care of the m squared times m to the third. So those are the same base, so all we need to do, because we're multiplying, is add the exponents. 2 plus 3 is 5, so my answer is 4m to the 5th power. Okay. Alright, this one, very similar to that first one. We're going to multiply the two numbers. They're not being raised to any exponents, so it's just 4 times 2, which is 8. Now we're going to deal with the like bases. So anytime you're multiplying and you have the same base, you can combine them by adding. 4 plus a negative 3 is 1. It's not necessary to write something to the first power, so you could just write it as 8 to the n. If you wrote it like this, it wouldn't be incorrect. So you can still do that, but you're more likely just to see 8. Okay, now this one. So notice the 3k to the 4th is in parentheses, which means that this 4 power is being raised to this one, but it's also being raised right here. So I'm going to write it out a little bit better for you. So this is actually saying we're doing 3 to the 4th power, and then we're also doing k to the 4th power to the 4th power. Okay, so the first thing we're going to do is we're going to figure out what is 3 to the 4th power. So it's 81, and then because we have a power to a power, that is when we multiply. And 4 times 4 is 16. So this answer is going to be 81k to the 16th power. Okay, very similar to that last one we just did. The 4r to the 0 power is in parentheses, which means that this 4 applies to that exponent, but it also applies to the 4 also. So I'm going to rewrite it. So we have 4 to the 4th, and then we have r to the 0 power to the 4th power. So let's clean this up a little bit. So the first thing we're going to do is we're going to figure out what 4 to the 4th power is. It's 256. Okay. This is a power being raised to a power. That is when you multiply. 0 times 4 is 0. And then don't forget that anything raised to the 0 power is actually 1. And then we can simplify. 256 times 1 is 256. Okay. Alright, so now we're getting a little bit trickier. Okay, so the first thing that I like to do is go ahead and take care of numbers that are just by themselves. So 4 divided by 4 actually cancels out, so I'm going to cross these out. It's not actually even there anymore. Okay? The next one, we have x squared and we have x. Because we are dividing, we're going to subtract those two. So 2 minus 1, remember that's an understood 1, is 1. Okay? Then you have y to the 0 power. Anything to the 0 power is just 1. Okay? And then we have this x to the negative 3. We never want negative exponents, so we're going to move it to its opposite position. So I'm going to move this to the bottom, and I'm going to make the exponent positive. So let's clean this up a little bit. Alright, x to the first power is x. X times 1 is just x. So this becomes x over z to the third power. Alright. So the first thing I do is I look for numbers by themselves. You just have a 3, so it's just going to stay 3 up on top. Alright, next I see that I have x to the third and I have x to the negative fourth. Because we are dividing, we're going to subtract. 3 minus a negative 4 is 7, so x to the 7th power. Next, I notice that I have these two y's, and because we're dividing, we're going to subtract the exponents. Negative 1 minus 0 is negative 1. Alright, and then I'm going to look at the two z's that I have, and because I'm dividing, I'm going to subtract again. So negative 1 minus 0 is negative 1. Okay, so remember, this is all over 1. So now I'm going to do just a little bit extra stuff. I never want a negative exponent, so I'm going to move it to its opposite position. I'm going to move it to the bottom. So I have 3x to the 7th on top. I have y to the first on the bottom. And then I also have z to the negative 1. I don't ever want a negative 1, so I'm going to move it to the bottom and make it positive. And that's going to be my answer. Alright, so you may have seen this, you may have not, but this is what we like to focus on in Math 3. So this is rewriting exponents and radicals. So if we notice in that first one, we have a radical function. We have a radical because that's what this is called right here. It's called a radical. And then the one on the right is just an exponent. It's a little confusing at first, but I just want you to notice where things are. Okay, so let's refer to this as the square root. Get it? Okay, whatever the number is right here, where the square would be, is going to become the denominator of the fraction. And whatever is the exponent on the variable inside the radical is going to become the numerator. So I like to say that this over here looks like a little house, and you just fill in the house. So let's say that there was a 3, that a cube root, this would be a 3 in the denominator. Let's say that there was a squared right here, this would be a 2 right here. So here's how this looks. The cube root of x squared equals x to the 2/3 power. So that's all that's saying. So that square and that triangle is just so you remember where things go. If you don't like that and you just understand that the number out here goes on the bottom, then that's what you do. The number inside goes on top, that's what you can do. So we're going to do some examples. Okay, first thing we're going to do is we're going to look on the left side and we're going to write it in simplest radical form. So that means it's going to be the radical part. So I'm going to draw my little house. It's like a little kindergarten house. Alright, and I know that this is going to be a radical because we're putting it in a radical form. And it's a square root. Oh, that's supposed to be yellow, sorry. Alright, and now we're just going to write the other stuff. Okay, so the 2x goes together in parentheses. 7 goes in the triangle. 3 goes in the square. And now I'm going to simplify it a little bit. So this is going to be the cube root 2 to the 7th power and x to the 7th power. Because remember, we're taking this exponent and we're distributing it to everything in that parentheses. So we are getting this radical in simplest form, which means that we have to figure out what 2 to the 7th power is. It's 128 x to the 7th power. So that's how you would write that in simplest radical form. Alright, now number 2. I'm going to do the same thing. I'm going to build the little house. Remember, we're talking about a square root. Sorry, it's so cheesy, but it helps some people. That's why I keep doing it. So 4x is what's going in the radical. 5 goes in the triangle. 2 goes on the outside. You do not need to write a 2 whenever it's a square root, because anytime you write this, it's an understood 2. Alright? So we have 4 to the 5th power, x to the 5th power. And if we're just going to simplify it, we just need to figure out what 4 to the 5th power is. So this is 1024 x to the 5th power. Now sometimes if you go into higher level math courses, they'll actually have you to break this radical down further, like we did in the quadratics unit. But I'm not going to right now, just because I want you to just understand the process of writing it. Alright, last one. So this one's a little bit different, because notice the 8x is not in parentheses. What that means is only this part is being raised to the 5/4 power. Okay, so I'm going to build the house. Remember, this is a square root, and the triangle goes inside. So the exponent only applies to the x, so it's the only thing that's going to go inside. There's a 4 and there's a 5. The 8 is kind of all alone just out here. So here's how this would look. 8 to the 4th root of x to the 5th power. Okay, so that's how you write it. Alright, and now we're going to do it the opposite way. So now we're going to write it in exponential form. Okay, so remember, it's a square root. Alright, and when we write it in exponential form, that's when we make the little house. Like this. Okay, so 3 goes on top, 5 goes on the bottom, so this is x to the 3/5 power. Alright, next one, it's kind of the same. We're talking about a square root, that's why the square goes on the outside. Okay, so notice that this is to the 1st power. And both of these things are inside, and they're both being raised to the 1st power. So we could write it like this. So the 9x is together, because it's both inside the radical. Alright, so now we're going to build the house. 1 goes in the triangle, 3 goes in the square. So this is 9x to the 1/3 power. And I'm going to say it again. You could simplify this further, but I just want you to understand writing it right now. Oh, I did not mean to mark on it like that. Alright, and now we're going to do the last one. Okay, so square. Oh, sorry. Alright. So the exponent on the x is 3, but the exponent on the 16 is only a 1. So I hope that makes sense, because it's not 16x to the third power, just the x is being raised to the third power. Okay, so we're going to do two different houses because we have two different things going on. Alright. Here's our triangle. Here's our square. And now we're just going to fill it in. This is a 1 over 4, and this is a 3 over 4. Alright, and let's just clean that up a little bit. So this is 16 to the 1/4 power. Remember, the 1's up there because there was an understood 1 exponent. X to the 3/4 power. That one has a different numerator because you had a 3 exponent. Okay, so that's how you write it. If you wanted to simplify, I mean, you could just do 16 to the 1/4 power, and it's actually 2x to the 3/4. But I just wanted you to get used to writing it right now, so I'm going to accept this answer. Just know that you would probably see this one in a higher level math course. Alright. So here is a final exam problem. It's been on the final exam before. I want you to take a moment, I want you to pause the video and see if you can figure out how to answer it. So pause the video in 1, 2, 3. Okay, so the first thing I hope you realize is that this exponent, because everything inside is in parentheses, is being applied to everything. Alright, so I'm going to write this out so you can see a little better, because that's really messy. Okay, so here's what I mean by the exponent is being applied to everything in there. Okay, so notice that this is just a number. I'm just going to type that into my calculator. I'm going to get a decimal, but I can always hit math, enter, enter, and it'll make it into a fraction. Alright, so that is actually 1/4. Everything else is an exponent to an exponent, meaning that you would multiply the exponents. So that's what I'm going to do next. Alright, and then if you'll notice that you have 2 that are negative, meaning that they would go on the bottom. So the answer is A. Now, if you wanted to save time and not do all of that, as soon as you got this right here and you got 1/4, A is the only one that has a 1 on top and a 4 on the bottom, so you actually could have stopped right there because it's a multiple choice. So that's a little test strategy just to save you some time and brain function. Alright, so try your assignment. Let me know if you have questions. Hopefully that made sense. If not, you can always message me for help. Bye!